Again, class, good evening. We are looking at the second section of chapter 2, the limit of a function. Okay, so actually the synopsis of that is given here. If you look at what we have at the bottom, the limit of f of x as x approaches a from the left. This notation means a from the left. This means a from the right. And if they are identical, okay, then the limit exists. And please understand the concept of a limit has got nothing to do with a functional value. So finding limits by numerical and graphical methods. There are really different methods of approaching them. We can do them numerically, graphically, or algebraically. Okay, so this is the synopsis of the section, class. First, the definition is that the limit of f of x as x approaches a equals L. Okay, so the limit of f of x as x approaches a equals a. That's how we read that. Okay. Then I want you to look at this right side of the page. This is the definition of VA. VA stands for vertical asymptotes. Vertical asymptotes, I hope you remember at the very least from, graphing rational functions, okay, vertical asymptotes. If the limit of f of x as x approaches some number, let's say a, whether it approaches a or from the left or right, it blows up to infinity or negative infinity, that line x equals a is the vertical asymptote. As you can see at the bottom of the page, we have what's called the one-sided limits. A function has a limit at a if the one-sided limits are identical. That means the limit from the left and right are the same. So this is the synopsis of the section. All right. Now, let's look at these pictures and see what's going on. In short, what you're looking at, three different pictures where all of them have the same limit as x approaches a, namely L. When we say the limit, we are looking at the y coordinate that could be, okay, and it may not exist. So please understand what's going on here, class. In this case, we are looking at a from the left and right. Okay, we are approaching it this way. From the left and right, we are approaching it this way. And in all cases, we end up with L. The same thing for this one, the same thing for this one, and all of the above. Okay. However, what is the difference? And that's what I want to discuss. If you look at the first case, also f of a equals L. Why is that? Because it's just continuous, and it's continuous function. There is no hole. If you look at part B, there is a hole here. So f of a is not equal to L. What is it equal to? To the y coordinate of the screen point, whatever it is. Okay. And in part C, there is a hole here. There is no solid point. I don't even know what's f of a. It's not defined. It's not given to us. So in part A, f of a equals L. In part E, f of a equals B. Now that we have this point, B, which is not equal to the limit. And in part C, f of a is not defined. It's not given. But in all cases, the limit exists and the limit is equal to L. And I hope you understand what happened here. If you could see what happens here, and if you could follow that, you are in good shape, everybody. Okay? Because that's really the idea behind the limits. All right. Now, let's take a look at this example. We want to guess the value of this limit. Of course, we ultimately don't guess, we do the work, but just to get things started. I hope you realize the function is not defined at x equals 1 because the denominator is x minus 1 times x plus 1. Okay, and this is what we are going to encounter in calculus. Most of the time we end up with situation such as this one. If you plug in, you get 0 over 0, which is known as indeterminate. So having said that, how do we approach that? There are a number of ways we can approach it, and I want to show you all of them. So numerically, you have to pick a number close to 1. So let's do that. Okay, again, tedious. It takes a little bit of a time. I'm not interested in doing this by really repeating this type of question, but it is worth looking at least one. So take a look at what happens here. Okay, we are approaching x. X approaches 1, but this time from the left. Take a look from the left. And what's happening? We get closer and closer to 1 here. Now let's do it from the right. Okay. So if you look at the second column, f of x, look at the last number. Why are we looking at the last number? Because this is the closest number to 1. So this is the answer for approaching it from the left. And this one from the right. And I hope you realize when you compare these two, and again, we can go further, okay, and get closer and closer to 1. I hope you see that you can easily see the limit must be 0.5 or 1/2. I hope you see that from the two tables. If we were to graph this, everybody, if we were to graph this, the graph will result in the same thing, okay? The graph will result in the same thing. Okay, there is a hole there. And by the way, I hope you realize and you remember, if you're graphing a rational function, first and foremost, simplify it, okay? And then you look for your vertical asymptotes. Now, what we really are interested in is the last methodology, which is the best methodology, which is what? Algebraic method. We can factor the denominator and x minus 1 drops. And by the way, if I were graphing the function, I would graph this one. Okay, f of x equals 1 over x plus 1, which is what you see. And there's a hole there because x can't be plus minus 1. Okay. And now if I plug in, I get to the same answer. And this is what I'm mainly interested in. Okay, class? So this is finding the limits. All right, one-sided limit, by definition, if you look at this limit, this limit only exists if this limit, that means x is approaching a from the right, this limit, that means x approaching a from the left, are identical, otherwise it doesn't exist. So if you look at this simple example, okay, by the way, it's called a Heaviside function in physics. If you look at the limit as t approaches 0 from the left, we use this function and get 0. From the right, we use this function, we get 1. And this is shows that the limit doesn't exist as x approaches 0, simply because the left and right, they don't result in identical limits. So having said that, I want to show you again how we do the reading. The symbol x approaches a from the right means that we consider only x larger than a. That's just making sure we understand the symbol. And the symbol x approaching a from the left means that we consider only x less than a. And here's the limit, okay? By the way, h of 0 is 1 class because this has equality here. So h of 0 is also 1. Just, you know, I thought it is a good idea to see that. Okay, so having said that, let's go to the next page. We have the graph, okay, and we want to come up with the following, okay. The limit, okay, again, I'm assuming everybody is comfortable with the graph and following him and they are looking at the graph. So here's what's happening. What is the limit of g of x as x approaches 2 from the left? So you locate the 2 along the x-axis. The left of 2 is this way, okay? And so what we have here, the left of 2, we are in this branch, is shooting towards this whole class, okay? So it's moving towards that. Remember, we are not interested in 2, we are interested in approaching 2 from the left. What is the y coordinate? 3. So the answer is 3 for this case. However, from the right, we are coming this way towards 2. So we are moving this way and we are approaching this hole. So from the right of number 2. From the right of number 2. And this one has y coordinate 1. Okay. And so what about the limit? The limit doesn't exist. Why is that? They are not identical. The limit doesn't exist because they are not identical. The limit only exists if they are identical. Okay. Now, number 5. So here's number 5. From the left, from the right. So from the left of 5, we go this way. That means in this branch, we are moving towards this point. And this point happen to have y coordinate, which is 2. From the right of 5, from the right of 5, that means this portion, we are moving towards the same point, same hole, which has the same y coordinate, which is again 2. Therefore, so this is 2, this is 2. Therefore, the limit exists and it is equal to number 2. Okay. Now, I want you to notice that if you're interested in functional value at 5, we want the y coordinate of this point, which is, of course, not equal to the limit. It seems to me that it's about maybe 1.4 or whatever that you read. I'm okay with that. I just want to point out that g of 5 is the y coordinate of this point, this solid point. Whatever you read, that's fine. The point being, it is not equal to 2, which means what? The limit exists, yes, because the limit from the left and right are the same. But is the function continuous? Because later on, when we look at the definition of a continuity, the answer is no. The function is not continuous. Okay. So example 3. Now let's look at the same concept. We are really interested in number 2. So from the left and from the right. From the left, we are in this branch and we are going here, okay? And we read the y coordinate to be 3. From the right, we are in this branch. We end up in this hole having the y coordinate of 1. They are not identical. The limit doesn't exist. So the limit from the left and right are different. Therefore, the limit does not exist. Okay. All right. Now, what about f of 2? I hope you see that f of 2 is, because this is a solid point, is this y coordinate of the point, okay? Which is number 3. 4, whether we come from the left and right, in this portion or in this portion, in both cases, we end up with the same hole. So the limit is equal to the y coordinate, which happened to be 4. However, when it's asking for f of 4, what is f of 4? Let's look for a solid point. I don't see any. So I don't have it. I don't know. It's undefined. Okay. We don't have it. It's undefined. Okay. All right. The infinite limits, just in short, I don't want to spend too much time on this. As you can see, x is approaching a. From the left, it goes to infinity. From the right, infinity. Both sides, infinity. This is from the left. This is from the right. And both sides, negative infinity. Therefore, it gives rise to the definition I put up for you. And just as an example, and I hope you remember the basic functions and their graphs, okay? So we can say the limit of ln x as x approaches 0 from the right is negative infinity. I hope you remember this simply because you are going to remember this graph, okay? Because you are going to remember this graph. So having said that, let's look at this case. we are looking at the limit of this function as x approaches 2. So I hope you realize whether we come from the left or right of the 2. In both cases, it blows down to negative infinity, okay? So this is negative infinity. However, 5, it blows up to positive infinity, okay? Now here's negative 3. From the left side is different. From the left side, it goes to negative infinity, but from the right side, it goes to positive infinity. So again, just reading from the graph. Therefore, take a look, class. VA, x equals 2, x equals 5, x equals negative 3. So because x is approaching 2 and we get negative infinity or positive, it doesn't matter, 2, 5, negative. You just want to make sure you just write down the equation. It's a vertical asymptote, x equals a number, class. It is x equals a number. All right. You want to find the vertical asymptotes. I hope you remember that y equals tan x looks almost like y equals x cubed, and there are infinitely many discontinuities and vertical asymptotes. One cycle goes from negative to positive pi over 2, okay? So the vertical asymptote is basically those. Or if you write it as sine over cosine, wherever cosine is 0, that would be VA, again, short for vertical asymptotes, okay? So the graph is, giving us the answer, also sine x over cosine x. So I hope you see that cosine x is 0, okay, at what points? So just to give you an idea and to refresh your memory, okay, so cosine x equals to 0, x is 2n plus y times pi over 2. That is the solution. I hope you remember it from trigonometry. 2n plus 1, that means odd multiples of pi over 2. I hope you remember when it's pi, it's negative 1. When it's 0, it's positive 1. Okay, so that's how we can see that. And obviously, this is pi over 2. Okay, from the left of that, like, okay, for example, maybe 89 degrees, just to give you an idea. It approaches infinity, but from the right of that, like 91 degrees, for example, is negative infinity. And so those are the VAs or vertical asymptotes. Okay. Okay. So vertical asymptotes 2n plus 1 times pi over 2 as n is an integer. And obviously the graph confirms it. Okay, class? Okay. All right. Let's look at the next example. We want to sketch this graph just to give you an idea, class. I hope you remember the graph of sine x and then cosine x and then this shoots up. Just a quick recap of what you probably remember. Okay, this was the graph of y equals sine x. I hope you remember that one. I'm just going with one cycle. And then you go indefinitely on both sides. This is 0. This is 2 pi. And again, you can go back to chapter 1. I have explained that there, everything over there. And for cosine, goes something like that. Okay. So if it's sine, it's that. If it's cosine, it's that. If it's 1 plus sine, basically it's the sine moved up by 1. So this thing goes up by 1. So when x is less than 0, and remember, this thing continues indefinitely on both sides. In other words, this thing continues indefinitely on both sides. So this one, for the first part, comes up, comes up by 1. So this goes here, and that would be the first part, and to the left of it, okay? Then you use cosine all the way to pi, and remember this is pi, by the way. I hope you remember this is pi -1, okay? And then after pi becomes sine again, okay? And pi is here, everybody. Okay, so let me write the pi for you. So pi is here. Okay, and so if you put them all together, this is the graph. I hope you're okay with that. So sketch the graph, and we want to find the limit of f of x as x approaches a, okay, if it exists. Okay, so basically, I hope you see that if you just by looking at the graph, okay, the function has limit everywhere except at this point. So let's discuss that from a calculus point of view. So from the left side, okay, the limit as x approaches pi from the left is the y coordinate here, which is -1. From the right is 0, so the limit doesn't exist. And f of pi is, because this is solid, is -1. Okay, so exists all as except at a equals pi, and here's the reason, everybody. Here's the reason. All right, we have a couple more minutes to finish this section, okay? Find the following limits. Now, class, what happens in calculus, most of the time, we approach it a very simple way by plugging the values. So simply plug in and observe, okay? So I hope you realize if you plug in for number 23, you get 0/0. So when we get 0/0 or infinity over infinity or infinity minus infinity, we need to do more work, okay, class? That's because they are called indeterminate. We will discuss that later on, but the terminology is indeterminate. All right, so how do we approach that? The technique is to multiply by the conjugate of the numerator, the top and the bottom. This is the technique, class. So we are looking at techniques for cases like this. So what happens is that, I hope you remember, this is a minus b, this is a plus b, so it becomes a squared minus b squared, and it comes out again. So it comes out as x plus 4 minus 2 squared, which is 4, and the denominator, you don't touch it, you write it as a product. So what happens? 4 and -4 cancel each other. Also, the x cancels out. And the numerator remains as 1 and 1 only. The denominator is the square root of x plus 4 plus 2. If you plug in, this becomes 2, and 2 becomes 4, 1/4. Now, how do we approach 29 and 30? Okay, I want to make sure we understand that one, class. It's extremely important to see the easy way out. We plug in. When you plug in, class, if you end up with a number, if you end up with any number, you're fine. If you end up with 0 over a number, you're fine because it becomes 0. If you end up with number over 0, you have to figure out if it's negative or positive infinity. So I hope you realize when you plug in both cases, okay, so -3, the top is -1 or close to -1. And in both cases, the bottom is 0. However, in this case, it's 0 from the right, and in this case, it's 0 from the left. So take a look at how you arrive at this answer. You can literally plug in. -3 from the right, like -2.9 plus 3 is a positive 0.1. And that's what gives rise to this 0 from the right. Why is this important? Any number over 0 is infinity. The only thing you need to figure out is the sign. So what is the sign? Negative over positive is negative infinity. If you look at this case, why is it 0 from the left? Let's just quickly understand the reason behind that one. Okay. -3 from the left is like -3.1 plus 3 is -0.1. Because it's negative, it gives rise to this negative sign here. So again, the answer, we know it's infinity, but we need the sign. The top is negative, the bottom is negative. Negative over negative is positive infinity. That's how you arrive at the answer. So we're going to practice this for one more page to make sure we are in good shape, and then we are going to move on. So here's the last page, everybody. Plug in. I hope you realize when you plug in what happens. Let's start with the first one. When you plug in 5 from the left, it's e to the power of 5. Whether 5 from the left, it's e to the power of 4.9, or from the right, 5.1. The top is almost the same. It is the bottom, which is 0, and I hope you realize 0 from the left. Why is that? Again, 5 from the left, like 4.9 minus 5 is negative. When you cube that, it is still negative. So the answer is negative infinity. However, we will look at the case where it's not in case. Okay, we will. Actually, I'm interested in looking at this one first. So how about if we look at the same case where the exponent is an even number? So I hope you realize this becomes e to the power of 5, but this time is 0 from the right, and therefore is positive infinity. And that's the difference between these two. Okay. Now for number 40, if you plug in, you get 0 over 0. The technique is factoring. Okay. Number 1, factor. Number 2, plug in. Now if I plug in, the top becomes 2. And again, class 2 is approaching from the left. So if you put 1.9999 or 2.11, it is still number 2. The denominator is 0. But is it 0 from the left or right? Remember, 2 from the left means 1.9, roughly, right? Let's say, for the sake of argument, so we can figure out. So it becomes what? Negative, so 0 from the left. So positive over negative gives us negative infinity, okay? And that's what I want you to be careful with. If you look at this example, you may know the answer is negative infinity because you may remember the graph, okay, class? This is the graph, okay, and this is x equals pi. This looks like minus pi, almost minus. You know, I'm sorry, the graph doesn't look good, but what can I tell you? Almost looking like y equals minus x cubed. So that's one way to do that, or you can simply go over the math, cosine over sine, okay? And this is negative 1 over 0 from the right because x is approaching pi from the left. I hope you remember that in the first and second quadrant, sine is positive. So when we say pi from the left, that means like 179 degrees, which is the second quadrant, and sine is positive. So the result negative over positive is negative infinity, okay? And this one, again, x is approaching 0 from the right. I hope you realize that sine of 0 becomes 0, and then it's from the right, like 1 degree, for example. So, and that by the graph, I hope you remember the answer is negative infinity. It goes back to remembering the graph of natural log function.